right, so that's all about support vector machines. Any questions you may have, we can take those and then we'll jump to the next lecture. Okay, question from Dominic. I think that's a good question. What's the difference between support vector classifiers and support vector machines? So support vector classifier was giving you like a linear boundary, right? And if you don't have like a plane which can separate like your classes, then support vector classifiers won't work. And that's why we needed like the kernel trick, where you can actually project your data into high dimensional space to make it linear. So at the end, support vector machine is also learning these linear boundaries, but it's actually using that transformation, okay, by forcing the data to high dimensional space. So that kernel trick is the difference between support vector machine and support vector classifier. Is that clear, Dominic?
Sorry, so the support vector classifiers are like really bad when you're not able to get a very linear boundary, is basically the main difference. Correct?
Right. Yeah.
Okay. Thank you.
And now this is going to be again one of the easier lecture we have, because most of this we have already covered. So this is kind of a review, I will say. Okay, so that I think is all for classifier, and I think we are almost out of time. So let's end it here. And if you have any questions, I'll be happy to answer. I think question from Amir. Those the number of parameters in FC and equivalent CNN is the same. Yes, they will be exactly the same. That's a good question, Amir. Okay, question from Ahmed. Can you please repeat the issue with softmax discussed in slide 26? Let's go there. All right. Right. So what? Okay, let's first quickly go over what softmax is doing, right? So let's say if you have three classes in your data set, right? So a network will make three predictions like this. And what softmax is trying to do is softmax is converting these predictions to probabilities like this, the green box. And the key property of this is sum of all these probabilities will have to be 1, and then only they are probabilities, right? Now the problem is, if you have a multi-label classification problem, then you might have multiple classes present in your input image. So in this case, it's just cat, but there might be a dog sitting behind the cat. So in that case, what will happen is both cat and dog will be positive, right? So then your probability for dog should be 1, cat should be 1. But then if you use softmax, because since the sum of like all the probabilities equals to 1, you will never get like probability of 1 for cat and dog independently. The max you can get is 0.5 and 0.5. Okay, and that's a hackman if you can use if you want, but again, it won't work because you don't know how many classes are present. So if 2 classes are present, then you can put a hack, okay, 0.5 will be like considered positive. But what if you have 3 classes? Then that hack will not work. Okay, what if 4 classes? So that's why you can't use softmax for multi-label classification, and using a sigmoid is advisable, because sigmoid doesn't look at like cross predictions. It just looks at the prediction itself and normalizes it between 0 and 1. Okay, so then in that case, multiple predictions can be 1. So I think it couldn't do. All right, good. So I think that was the only question. Any other question you have before we end? If not, then let's end it here. Okay. Thank you all, and I think I will see you on Tuesday.